Hello auditors, welcome to Ethernaut Preservation Challenge. You can see that in order to solve this challenge, you must be a master of delegate call and you must become the owner of this particular contract. And you can see that this is the code. Let's dive into the code. Now, over here we got these codes that we have copied from Ethernaut. You have some simple slot 0, slot 1, slot 2, slot 3. And then this is a function signature for delegate call, a simple constructor, and there's two functions using a delegate call which actually call this particular signature. It's the same thing. And then over here you can see that this particular library contract is actually used for this particular delegate call as well. So what delegate call is that let's say that we have this particular preservation contract delegate call here. So what this means is that this will be run as though it is inside this particular contract. So it's like an extended form. So this is P and this is L. So this actually makes into one. So if you understand the previous challenges that I've did on delegation, the delegate call challenge on Ethernaut is very similar. So over here we got this store time which is at slot 0, and over here you have 0, 1, 2, 3. And since start time is not at slot 3, when we call this particular function, you will actually set the time into this particular contract address. So basically we can set any address we want, but firstly we have to convert it from address to uint256, and in order to do that is because of this particular parameter. So we have to first convert to 160 of this address and convert to 256, and when we store it will basically convert back to address. It's quite simple. And let's move on. So when we call, that's the first time when we call the particular function, and since there is no more slots, there's only 0 and there's no more slots. So when we call this particular function again, we pass in the address of this particular contract, which means that it is our smart contract, the hacker address. So what this does is that it will perform a delegate call which call this particular ABI signature. This function signature is actually calling this particular attack contract, and since there isn't one, we can create our own malicious function which actually sets the owner to us. So since we pass in the uint, let's change the number, change our color. So basically it's uint 256 is passed into here, which is from here to here, and then we will actually convert it back to address, which is us. And since this is delegate call from this particular contract to this particular contract, so what this does is that this contract is run as though this is extended. So this is P and this is A. So this is like an extended version. Therefore, we have actually solved the particular challenge. And in Brownie, you can see that it's actually quite simple. We just deploy the contract and call the pawn function. Let's just run it. So I'll pause right here. Okay, you can see that the transaction has been completed and has been mined. And when I actually submitted the transaction, let's just wait. We've actually completed the challenge. So if you guys like this particular tutorial, please hit the like button and subscribe. Thank you for watching and have a nice day.